Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good day everyone. My name is Siti Rahimah binti Batcha. You can call me Miss Rahimah. So, I am one of the lecturer from KPPIM. So today in this video, I will show you how to answer final examination questions for MAT 435 Calculus for Engineers. So I will show you how to answer based on the past year exam paper. I will start with chapter 1. Let's go. So in chapter 1, you learn about methods of integrations. So we have 4 methods, which is integration by parts, integrations of trigonometric functions, integrations of trigonometric substitutions, and also integrations of rational function. So I will show you example on each of the methods, right? Okay, for the first one, we have past year exam paper on July 2022. So question 1, we have solved integral of x cubed over square root of x squared plus 1 dx using trigonometric substitution. So the methods used already mentioned here. So first step, what you need to do is write down the question first. We have integral of x cubed over square root of x squared plus 1 dx. So because we need to use trigonometric substitutions, so we look at the radical form in the functions in the denominator parts first. Okay, so here we have square root of x squared plus 1. So step 1, we need to identify this form. So this form is in the form of square root of u squared plus a squared. So if we have our radical in this form, we need to let u to be equals to a tangent theta. So here we have our u x squared, our a 1 squared. Okay, therefore here u will become x, a will become 1, so no need to write down. So we have tangent theta. Okay, so second step, we need to differentiate the x. Okay, so differentiate x equals to tangent theta will be dx over d theta. Tangent will become secant squared theta. Alright, after that, okay, so I write here. So third step, okay, for the third step, we take out our radical function, radical form on the denominator. We have square root of x squared plus 1. So change this one in terms of theta. So x just now, we have x equals to tangent theta. So if we have x squared, it will become tangent squared theta and then plus 1. Okay, we look here, we can see that this one we can change into secant by using identity. So tangent squared theta plus 1 is also equals to square root of secant squared theta. So here we have squared, here we have square root, so we can cancel these two. It will become secant theta. Alright, so next step, we take this integral and change everything in terms of theta. Okay, so that we can integrate with respect to theta. Okay, so here we have dx. Alright, so we change everything. X cubed, okay, our x just now is tangent theta. Therefore, here will become tangent cube theta. Divide by square root of x squared plus 1. This one is equals to secant theta. So we have secant theta, secant theta. And then our dx here, okay, dx comes from here. So here dx over d theta, we bring d d theta to the right hand side, we have dx equals to we have secant squared theta d theta, right? So here we have secant, dx will become secant squared theta d theta. Okay, so as we can see here, we can cancel out this secant and here, one of the secant here, right? Therefore, it will become tangent cube theta secant theta d theta. So now we can integrate this one, but we cannot straightly integrate. We need to apply another method. So we will use U substitution for trigonometry. So here we have tangent cube secant theta. Okay, so we can use, let U to be secant theta, alright, and then differentiate du d theta, we get secant theta tangent theta. So because later we will change, we will substitute here d theta, so we make d theta to become the subject. Okay, therefore we have d theta equals to du over secant theta tangent theta. Alright, so next, because we want to have everything in terms of du, okay, with respect to u, so that we can integrate. So tangent here, we need to do something here. So we need to change this one to be, first we need to take out one of the tangent out. So we become tangent squared theta, tangent theta, secant theta, d theta. Alright, after that here, tangent squared, we use identity. We get secant squared theta minus 1. Okay, bracket. And then we have tangent theta, secant theta, d theta. So this one later on will be cancelled out with this secant theta, tangent theta here. Okay. Alright. Okay, don't have enough space. Okay. So substitute everything in terms of u into this function. We will straightly get. Okay. So here, secant here. Remember, we let u equals to secant, so therefore secant squared theta will become u squared. Okay, u squared minus 1. Okay, tangent theta secant theta here. Okay, remember we will substitute d theta here with this du over secant theta tangent theta. Therefore, this here, okay, will cancel this one. So we are left with du. Okay. Alright. So we have integral of u squared minus 1 du. So we can straightly integrate. So we get u power of 3 over 3 minus u. Don't forget to plus c because this is indefinite integral. Okay. But this is not the final answer. We need to change back this one in terms of our trigo just now. Alright. So I don't have enough space, so I write here. Okay, so 5. Substitute back. Okay, u cube here. U just now is secant. So we have secant cube theta over 3. Sorry, so we have... Okay, so just right here, number 5. Okay, number 5, we substitute back. Therefore, we have secant cube theta over 3 minus secant theta plus c Alright, so after we substitute back, remember our questions, the function given is in terms of x. So we need to have our final answer in terms of x also. Alright, so secant, how to change secant cube theta here to be in terms of x? So go back to where is it? Okay, this one. Go back to this one. Remember, secant theta here, okay, secant theta here is equals to this one. Okay, so we substitute this one as our secant theta. So this one will be secant cube. So we have square root of x squared plus 1 cube. Okay, over 3 minus secant theta, this one. Okay, squared plus 1 and then just plus c. So this is our final answer. So if you do not write this one, then you will lose 1 marks. Okay, so remember, because the question is in terms of x, so leave your answer with this one. Okay, don't leave your answer in this form, but in this form. Okay, so this is for the first one. Okay, for the next questions, still in July 2022, for question B, use partial fractions to evaluate integral of 3 minus 2x over x minus 2x squared plus 4 dx. Okay, so we write down the integral first. Okay, when you write down questions, make sure to double check because there are students who copy down the wrong questions. Okay, so always double check. Okay, so first step, we take out this function, the integrand inside. So we have 3 minus 2x over x minus 2x squared plus 4. Okay, so now we will decide our partial fractions that we're going to use. Alright, so here on the denominator part, we can see here we have factor in linear form, another factor in quadratic form. So therefore, our partial fractions will be a over x minus 2 plus this one. For quadratic, we will have bx plus c divided by x squared plus 4. Okay, and then we take the numerator part. Okay, so we have 3 minus 2x equals to, so a here, the denominator parts, we only have the linear factor. Therefore, we need to multiply by x squared plus 4 on the numerator and denominator. Therefore, our a will multiply with x squared plus 4. And then plus b. So for b, the denominator parts, we only have the quadratic form x squared plus 4. Okay, then we need to multiply with the linear factor here, x minus 2. Okay, on numerator and denominator. But this one, I only write the numerator parts because we already make the denominator for all the fraction to be equal to each other. Okay, so here we have bx plus c. Okay, sorry. Bx plus c. Okay, bracket, don't forget the bracket. Okay, because we have operations here, so everything on the numerator must be multiplied by the factor. So make sure to put your bracket like this. Okay, so now next step, we want to solve the unknown a, b and c. Okay, so how to solve? We have two methods: compare coefficients and also substitutions. So for this example, I will use substitution method. Okay, where we will substitute the value of x. Okay, so you can substitute any value, but make sure the value of x that you substitute will help you to solve the unknown. Alright, so for the first x, I will substitute x equals to 2. Why? Because when we substitute x equals to 2 here, okay, we get 0. Therefore, this term will no longer be here, and then we can solve for a. Alright, so x equals to 2. So substitute 3. Okay, substitute here. We have 3 minus 2 multiplied by 2 equals to a. 2 squared plus 4, and then plus with b multiplied by 2 plus c. Here we have 2 minus 2. So here we get 0, therefore this term will be gone. Right, so we have here 3 minus 2 multiplied by 2 is 4, so we get negative 1. Alright, so here a, 2 power of 2 plus 4, we get 8. So we have this, and then this one already gone, and then we can solve for a. So a will be equals to negative 1 over 8. Okay, so we're done with a. So next, we still need to substitute value of x. Okay, so next substitution, we can substitute x equals to 0. Okay, substitute x equals to 0. So that, okay, from here we will get b equals to 0. Okay, and then we can solve for c. Right, so we will have 3 minus 2 multiplied by 0, and then we have a, 0 squared plus 4 plus b multiplied by 0 plus c, 0 minus 2. Okay, so here we already have value of a, so we can substitute. So we have 3. Okay, here becomes 0 equals to our a just now, negative 1 over 8. Okay, here 0 plus 0 squared plus 4, we get 4. Okay, here we get 0 for b, and then we only have c inside of this bracket. 0 minus 2, we get negative 2. Okay, so solve for this one, you will get the value of c equals to negative 7 over 4. Okay, so we already have our a and c. Now we want to solve for b. Okay, so for b, actually you can substitute any value because we already have a and c. Okay, so any value of x will help you get b. Okay, so for this one, we can choose smaller value. Okay, smaller number. So I substitute 1. So when we substitute 1, we have 3 minus 2, 1 equals 2. Our a just now, we already have our a, so we can substitute. So we have negative 1 over 8. Okay, 1 squared plus 4 plus, okay, bracket b multiplied by 1 plus negative 7 over 4 is our value of c. Okay, and then here we have 1 minus 2. Like that. Alright, so here simplify, we get 1 equals to negative 1 over 8. Here we get 5 plus b. Okay, and then we have here negative 7 over 4 multiplied by negative 1. Okay, so we get plus 7 over 4. So solve for this, we get our b equals to 1 over 8. Okay, alright, so we are done with substitution. So third step, okay, we will write our function here. Okay, our integrand here. And then we will substitute our value of A, B, and C. Okay, so over x minus 2 x squared plus 4 will be equals to, so A, we have negative 1 over 8, so we have negative 1 over 8 multiplied by x minus 2. Alright, plus, and then our B is 1 over 8, so we have, here we have x, okay, we have x, so we have x over 8, okay, x squared plus 4. And then we have C plus, our C just now, negative 7 over 4, so we have minus, okay, not plus, minus. Multiplied by x squared plus 4. Okay, so this is our partial fractions. And then next step, we will solve the integral. Right, so that one I will continue on the next page. Alright, so for the next step, we will write back everything in the integral form. Alright, so we have here, we write down the integral given first on the left hand side. X minus 2 x squared plus 4 dx. Okay, on the right hand side, we just substitute back our partial fractions. So negative 1 over 8, and then x minus 2 plus x over 8 x squared plus 4 minus 7 over 4 x squared plus 4 dx. Okay, now we will integrate each of these terms first separately. Depends, if you want to do straightly also can, or if you want to do separately also can, but make sure at the last step you combine everything together. Okay, so we do it separately. So we will integrate this one first. Integrations of negative 1 over 8 x minus 2, okay, dx. So this one we can straightly integrate because we only have x minus 2 in the denominator part, so we no need to use any method. Okay, so just integrate, we get negative 1 over 8 ln, sorry, not ln, natural log, okay, x minus 2 plus c. Okay, so second terms here, we have integrations of x over 8 x squared plus 4 dx. So for these functions, we cannot straightly integrate. We need to apply substitution methods. Alright, so we will let you to be x squared plus 4. Differentiate, we get to x. So change this form so that the x will become the subject, because later we will substitute here. We have dx equals to du over 2x. Alright, okay, so now substitute back everything. So here, okay, so x here on the numerator will cancel with this one, with this x here, and then but we still have 2, sorry, 2 here we need to write back. Okay, so we will have 1 on the numerator parts, and then we have 2 on the denominator parts. Okay, our 8 here can write inside of the integral or outside. Okay, so it depends. It's okay, both also correct. Okay, so I just put 8 here first, and then x squared plus 4 here, x squared plus 4 here. Okay, we change to u. This one. So we have u. Okay. And then we have our du only, because to just now we already write here, okay, here, and then our x here, we already cancel out with the x on the numerator. Okay, so simplify this one first. So 2 multiplied by 8, we get 16. So we can put outside of the integral. So we have 1 over 16. Okay, inside of the integral, we have 1 over u du. Okay, now we can integrate this one. So integrate this one, you get 1 over 16 natural log u plus c. But don't leave your answer like this, okay? Because this is when we apply u substitution. So we need to change back this one in terms of x. Therefore, we get 1 over 16 natural log x squared plus 4 plus c. Okay, so this is for the second term, and the third term here, we have integrations of negative 7 over 4 x squared plus 4. So for this part, we can see that we have squared on the denominator and then plus 4 here. So we will use, and if we use u substitution, we cannot solve. So we use the formula because we do not have any variable x on the numerator. So therefore we will get negative 7 over 8 tangent inverse x over, this is our a squared, so x is over a, so we get 2 plus c. So you can check your formula. Okay, you can check your formula on how to get tangent inverse. Alright, so this is for the third term. Okay, don't forget, for the final answer, we already integrate each of the term, and then for the final answer, step 6. Okay, so write everything back, combine everything together. So integrations of 3 minus 2x over x minus 2 x squared plus 4 dx is equals to, write everything. Okay, the first term, this one is the first term, so we get negative 1 over 8 natural log x minus 2, so plus d, no need to write first. Okay, we write at the end of the term, at the end of the answer. Alright, second one, we have this one, so we have plus 1 over 16 natural log x squared plus 4, and then the third term we have this minus 7 over 8 tangent inverse x over 2, and then don't forget 2 plus c. That's it. Okay, so we will continue with the next questions. Okay, for the next one, we have June 2019, question 1. Evaluate integral of natural log x to the power of 2 dx from 1 to e. Okay, e is exponent 1. Alright, so we need to use integration by parts, already mentioned here. Okay, so first step, copy down the integral. So always make sure to double check that you write down the correct equations or functions. Okay, so we need to use integration by part. Therefore, first step, we need to choose our u and dv. Okay, so how to choose u? You can use liate, L-I-A-T-E, okay, where log will be our first priority to become u. Okay, for this integrand, inside of this integral, okay, we only have one function, which is natural log x to the power of 2. Therefore, our u will become natural log x to the power of 2. So how about dv? dv will take dx. Okay. And then for u, we need to differentiate. So du over dx, we get 2. Okay, differentiate power outside first, and then write back the function inside the bracket, and then differentiate function inside the bracket. We have 1 over x. Okay, so this one, just rearrange, we get 2 natural log x over x. Okay, and then for dv, we need to integrate. Integrate become v equals to x. Right? Integrate dv become v, integrate dx become x. And then second step, we need to substitute everything. Okay, we need to substitute everything back into the formula of integration by parts. So integrations of, okay, so we leave the limit first, okay, upper bound and lower bound first. We solve the integral first. So natural log x power of 2 dx equals to our formula for integration by parts, ub minus integration of v du. Alright, so substitute everything, our u, v du. Therefore, we get our u just now. U is our natural log x to the power of 2. Our v is our x minus with integral of v, which is x. Okay, our du, okay, so du, we take 2x over x, and don't forget we need to also take dx, okay, because this one d over dx. Okay, so dx we need to bring to right hand side, so we have dx here. Okay, so for this part, we have x natural log x squared, okay, minus with, so 2 we can take out because this is a constant. So inside of the integral, x and x we can cancel out. We only have natural log x dx. So still we cannot integrate directly this one. Okay, we still have natural log x. Therefore, we need to reapply our integrations by part. So repeat. Integrations by parts for this one, okay, for this term right here. Alright, so repeat. We will have u, we will let u to be natural log x, so du over dx will become 1 over x. Okay, so it become dx equals to du over x. Okay, and then for our dx, dv, sorry, dv will become dx, integrate, we get v equals to x. Okay, so next step, step 4. Alright, substitute everything including the terms here. Okay, so we have x natural log x squared minus 2, put everything inside of the bracket. So we have our formula of integration by parts, our u natural log x, our v which is x, minus integral of v which is x, our du just now, du over x. Okay, this one. Alright, so now we have x natural log x squared minus 2, and then inside of the bracket we have x natural log x, okay, minus this one cancel out, we get integrations of du. So now we can straightly integrate this part. So we have x natural log x squared minus 2. Inside of the bracket we have x natural log x minus integrate of this one. Sorry, I make a mistake here. It's supposed to be x. Okay, so du, okay. Here is dx. Okay, sorry. Okay. Okay, du. Okay, sorry. So here supposed to be du dx. Okay. It was here also dx. Okay, we cannot, because we need to have everything in the same term. Okay, x, everything is in x. Okay, so here we get x. So plus c at the end of it. Okay, so change back here. Du equals to dx. Okay, du equals to dx over x. Okay, so this is the correct one. Okay, differentiate, and then we take dx to go to the right hand side. Okay, and then we can simplify. We get x natural log x squared minus, okay, so 2x natural log x minus 2x plus c. So this is the final answer. Okay, so this is for integrations by part. Okay, so just now, it's not the final answer yet. Remember, we have boundary given. So this is definite integral. So we definitely need to substitute the boundary given. So just write down the answer, the integral given in the question first on the left hand side, and then our solutions on the right hand side. Okay, x natural log x squared minus 2x, okay, natural log x minus x, okay, and then we have our boundary from 1 until exponent or e, okay, and then substitute the upper boundary into x. So we have e natural log e squared minus 2 e natural log e minus e, okay, and then substitute the lower boundary here. We have 1 natural log 1 squared minus 2. Here we have 1 multiplied by, so if you do not want to write 1 point, also can, okay, no problem. So we get log 1 natural log 1 minus 1, okay, like this. Okay, and then solve this one. We get exponent minus 2, exponent plus 2 e, okay, minus with 2. And then the final answer will be exponent minus 2. Okay, so this is the final answer. Okay, if you do not do this one, you just stop at after you integrate. You did not substitute, then you will lose 2 marks. Okay. Okay. Alright, for the next questions, we have June 2019, question 2. Solve integral of cos squared x sine 2x dx. The first step, write down the integral. Okay, so now we have our integrand in terms of trigonometric functions. Therefore, we will use trigonometric substitutions. Okay, use substitutions involving trigonometric because we have cos and sine here. But first, before we use the method, we need to change sine to x here because here the angles is different, so it's difficult for us to do the substitution. So we need to make the angle to be the same first. If in terms of x, both need to be in terms of x. So how to change? So look here. So sine 2x, we can use double angle identity. Change it to become 2 sine x cos x. Okay, based on double angle identity, right? Therefore, we have cos squared x sine. So we have 2 in front. Okay, here because we have 2 here, so we have 2 cos squared x sine x cos x dx. Okay, and then cos and cos we can combine. We will have 2 cos cube x sine x dx, right? And then we can apply our substitution. So because cos here we have cos, the power is 3, so we let u to be cos x. Okay, so differentiate du over dx, we get negative sine x. Okay. Therefore we have du equals to negative sine x dx. Okay, this is the first step, and then we let u our second step. Okay, so our third step will be substitute everything into the integral. Okay, transform this integral to be in terms of du. Okay, so integral of cos, so we take the one that we already changed the sine to x just now, this one. Okay, so take this one. Okay, so we have 2 cos cube x sine x dx equals to integral of 2, our cos just now, remember we let u equals to cos x here, so this one will become u cube. Okay, so for this sine x here, okay, here our dx is actually equals to du over negative sine x. So negative sine x here will cancel out sine x here. Okay, when we substitute the x to be du over negative sine x, right? So we will have du over negative 1 only because we have negative in front of our sine. So this one we get negative 2, take out these 2 outside together with the negative 1, so we have integrations of u to the power of 3 du. So now we can integrate. So we have negative 2 u power of 3, integrate, we get u 4 over 4 plus c. Alright, so don't leave your answer like this. We need to change back our u to become trigonometric function. So negative 2, our u just now is cos, so we have cos 4 to the power of 4 x over 4 plus c, and then these 2 we can simplify, we get negative cos power of 4x over 2 plus c. So this is the final answer. So that's all for chapter 1. I hope you can understand everything and apply it to the rest of the past year examination paper. And I will see you on the next video for chapter 2. Thank you.